Hey, what's up, people? I've got this little device sitting here on the bench today that I want to take a look at. And if we take a close look at the front of it, we can see that it's here on this obnoxiously reflective piece of plexiglass. It says that it's a RGBS/VGA to YPbPr. And I'm going to be using this along with that Philips TV that I've been messing with, the one that I was trying to get RGB inputs working on. And I can hear some people saying like, "Oh no, not that TV again." Well, yes, but actually no. We're not actually going to be doing anything to the TV itself, like trying to be anything with RGB input anymore. We're just going to be using it to display a video. And so what this device here does is that it'll take RGB and composite sync signals or VGA signals with horizontal and separate horizontal and vertical. It'll convert that into component outputs, which is what's up here on the device. And so if you take a look at the periphery of this device, we can see that on the bottom here, we've got a SCART connector. And this connector here will accept red, green, and blue video signals along with the component or the composite sync signal. And it can also take in the audio and output it on the RCAs that are right here in the back. On the right-hand side of the device here, we see that we've got an audio input as well as a VGA input here. And this VGA input will take the three color signals, the red, green, and the blue, as well as the horizontal and the vertical, and it converts that and outputs the component signals out through here in the back. The audio signal, there is no processing for, and actually it's all tied in together with the audio inputs on the SCART connector here. And it just basically, it's all just straight through onto the RCAs here in the back, which we can take a look at now. So we see we got the left and the right connector there for audio, and then we've got the component output here. So we see that we've got Y here in the middle, and then we've got PB, CB here on the right-hand side, and then PR, CR right here on the left-hand side. And if we keep going, we see we've got a small USB-C connector right there, and that's only to provide power to this device. But this device can also accept power from the SCART connector. If we were to, have something plugged in that was providing like 5 volts or whatever, it would power this device as well. Now, unfortunately, I don't have like a SCART little hood or connector or something that I can use to like plug into here and input stuff into this little box. So what I've done is I'm actually using the VGA connector here. Got a 15-pin connector right here. And I'm going to explain what all this wonderful mess of cables and wires and stuff like back here is here in a minute. But I did have to modify this just a tiny little bit, and it wasn't really too much of a modification as much as it was just adding a separate wire. And as I mentioned, this accepts the RGB and the horizontal and vertical signals. I'm going to be messing with the composite sync signal, so I needed a pin here that could accept the composite sync signals and couple it into the rest of the circuitry. So what I did is I used one of the unused pins that wasn't connected to anything else on this board, and I'm using that as the input for the composite sync signal. So all I did was take one wire that goes from that unused pin and couples it over to where the composite sync goes into the little IC that's inside of the, or not inside, but like on the board that we can see that it's just right there. So this device, I kind of wanted to give a shot because I wanted something that does not introduce like any sort of like video processing or anything like that. We want the input to be as like, low latency as possible on the output. And so what this thing has inside is a total of 4 ICs. One of the ICs is a VA7230LS. And that chip there, if you take a look at the data sheet, that's an NTSC color TV signal encoder. And so the main purpose of that chip on this board is converting the RGB and the sync signals, converts those into the component signals for the output. And it looks like it can do a little more than that. If we take a look here at the diagram for it, we can see that it looks like it'll take in basically a component input, and it can convert that into like a regular video output. And it looks like it's got 2 separate sections here from what I can tell. The portion that it seems to be using is down here where it takes where is it? So the analog red, analog blue, and analog green. It takes those, and that's how it converts it into the component output. We see right there we've got the Y out, the R minus Y out. and the, where is it? The B minus Y out. So that's the component outputs. And yeah, looking at the board, it's pretty obvious that it's not using like this portion of the chip, because most of the pins that are being used and where the traces go seems to be mostly on this side. So yeah, this is the chip that's doing like all the actual like video conversion. One of the other ICs on the board is an LM1881. And if we take a look at the datasheet for that, that's a video sync separator. And I believe what this is being used for here on the board, judging by the way it appears to be connected, is that it's just basically cleaning up the composite sync input, because you could input a composite video signal into it, and what it'll do is it'll just strip the sync information and output it via this composite sync output. It will also output a vertical sync on this pin right here on pin number 3, but it looks like it's only using pin number 1. So if you input a video signal as the sync source, then you'll get just a clean composite sync output on pin number 1. So after this is cleaned up, then this output here gets coupled into the component Y output, and that's how it outputs a sync signal on the component side. Another IC being used on the video conversion side is a THS7316. And looking at the datasheet for that, it says it's a 3-channel HDTV video amplifier with 5th order filters and 6 dB gain. So this appears to just be an amplifier. It's taking the YPbPr signals output from the other BA chip, and it's just amplifying that for output on the component side. And the fourth IC that we can see close to the VGA connector, that's a 74LS86, and what that is, it's just a quadruple 2-input exclusive OR gates. So those are being used for converting the horizontal and vertical sync coming into the VGA connector, and converting those into a composite sync. And if you happen to watch the last video I did about the Philips TV, where I mentioned that I couldn't get the RGB inputs to work, I made a mention about how I tried to even use a Raspberry Pi with a little VGA connector, and that I had taken the horizontal and the vertical outputs and put those through a little circuit that I had on the breadboard, and that was converting the horizontal and the vertical into composite sync. It's basically the same exact circuit, and this is the schematic that I was working off of, and as you can see, it's using a 74LS86 right there. It's got a couple of capacitors, a couple of resistors, and so that's where it takes the horizontal sync and the vertical sync, and that outputs a composite sync. It looks like this is completely identical to that. It might be wired a little bit different in where some of the outputs and some of the inputs go, but other than that, it's like the exact same circuit. And just in case you're curious, where I found this circuit was here on epanorama.net. It's a VGA to RGB plus composite sync converter, and it talks a little bit about it here. They got several examples, like this one here. Outputs a slightly lower voltage signal, but it tells you, how it works and all that stuff. It gives you like a few variations of it. So if you're interested in that, I'll probably leave a link to this down below. And this circuit does work pretty well. So it worked for me. It's being implemented on this converter, so it's a pretty good circuit. The 3 potentiometers that we can see up here on the top, as we can see, they say R, G, and B. So their only function is to adjust the voltage level of the red, green, and blue signals coming into the SCART or the VGA input, and how much of that gets into the NTSC color TV signal encoder IC. So when they're all the way clockwise, that's like maximum signal. And if we turn them all the way counterclockwise, then that's like very, very minimum signal that's getting into the encoder. Right, so what's this mess of cables that we can see right here on the bench? Well, it's a lot more simpler than it looks, but this device here, this little box, this is a video distribution amplifier. So what this is doing is it's taking a composite video signal and it's splitting it up into 3 outputs. On the PS2 that I've got sitting here to the side, I've got this connector here that's just mounted on the board that I took out of something, and I'm just using this to interface the 3 color signals as well as the composite video signal, and using that to output onto the rest of this other stuff over here. I've also got audio coming out of it, although I'm not really doing much with that. I'm mostly interested in the video signals. And I mean, it looks like a lot, but it's really simple if I explain it with a little diagram. So we've got the PS2 sitting right here, and we've got 4 different signals coming out of it. We've got the composite video signal that's going into the distribution amplifier. And the reason I'm doing that is so that I don't load it down with all the stuff that's going to be connected to it. So one goes out to the PC capture card. One output goes to cute little 9-inch Trinitron that I've got sitting over here on the side. And then one of the outputs goes into the RGB to YPbPr converter. And that's the little box that we've been talking about here. So the 3 color signals go directly into the converter. And on the output, the component, that's going out to the Philips TV. The only things not shown on here are the power going into the distribution amplifier, the power going into the converter, and we're not showing the audio lines either because, like I said, I'm not too interested in the audio lines. I was just doing that when I was trying to test the setup, make sure that everything was working. So this 15-pin connector right here, this is going to plug into the converter box. And what this has is got the red, green, and the blue video signals, ground, and it's also got a composite video signal coming in. Now, I did have to modify this a little bit due to the fact that it only accepts the red, green, and blue and the horizontal and vertical inputs, and it does not accept the composite sync on any of the pins. So what I did is I looked for one of the pins here that wasn't used for anything, that was not soldered to like any points on the board, no grounds or anything like that. And I put a little wire between that pin and where it goes to on the LM1881. So that way I could feed the composite sync signal into the chip there and, you know, it would function as normal. So yeah, this is going to plug into there like that. And then on the back side here, we're going to plug in the component cables and a USB-C for power. And that's it. Okay, now I've just got to turn the power supply on. And this thing here should come on. It's got a red LED right there on the side indicating that it's getting power. Distribution amplifier, it's got a green LED there indicating that it's getting power. And so now all I have to do now is turn the PS2 on. And if we turn on the capture there, we see we are getting capturing input. So it's working, but it's not the input here that we're interested in. So I'm just going to turn this off. Now these two here are what I'm most interested in. And I've turned off the lights so that we don't have like a lot of glare and stuff off the glass of the tubes. Unfortunately, I can't move this camera any further due to the fact that it's hooked up with HDMI to the rest of my setup here. And I don't have any longer cables. So as we can see, we've got video... static. We've got video output on both of the TVs, and this little tiny Sony one here is taking just the composite video input. This one here is taking the component video input, and I kind of want to see, I don't even know if I'm going to be able to test this, to be honest. It's all experimental, but I want to see if there's any noticeable latency between just capturing video like straight out of the connector out of the PS2 and going through the little box and converting it over to component video, or if it's pretty, I'm pretty sure it's going to be like pretty negligible if there's anything. Obviously here we can kind of see that like everything's kind of going at the same rate. There's like no noticeable delay between one or the other. If anything, this one here would be getting the signal before this one does due to the fact that it's getting the composite video signal before it gets processed. And after processing, that's where this one gets it. Now, as far as the video quality itself goes, this actually looks pretty good. The only thing I'm noticing here is that this looks a little bit kind of washed out, and it looks like we've got a little too much brightness, but I think that may be just like a menu thing here. I might turn this down a little bit. Let's turn it down to 50. Oh yeah, that's much better. So yeah, I think I just had the brightness up a little too high on that. But yeah, this looks pretty good. I don't see like any interference or anything like that going on. So I'm actually pretty happy with that. The colors look pretty good, but I do have all the potentiometers like turned all the way up. So as far as the image quality goes, it's really not messing it up or anything like that. So I'm pretty happy with that. Now, what I'm going to try to do is, since I don't have like a high-speed camera or anything like that, I'm going to try to set up my Pixel 7 Pro and put it on the slow motion mode. I'm going to put the camera like right here in front of these two TVs. And I'm just going to record a little bit of footage. And then I'm just going to go through like the menu and like scroll around and stuff and see if we can notice like any difference about when each like TV, you know, reacts to the video input. So maybe we'll get some information out of that. I'm not entirely sure. The other thing I can do is I can hook up the outputs into the scope, which is honestly probably going to be the better test. And I guess I could have thought of that before, but let's see what we can capture with visually and see if there's a noticeable difference in latency. So we'll try that first. All right, so I made it a little darker in here, and I'm about to start capturing video. So here we go. Okay, phone is recording. I'm just going to kind of like browse around here in the menu. And that should be plenty. All right, so that's plenty of that. I'll review the footage here in a little bit, but I think, like I said, we'd get a little bit more useful information if we use the scope here. So I'm going to turn that on, and I'm going to hook up one of the inputs directly to the composite video output, which is the one coming into here, into the distribution amplifier. That's coming straight from the PS2. And then the other side, we're going to take from the output here on the component side. So I'm going to take this off right here, and I will see how much of a delay there is between this video input coming into the distribution amplifier and the output right here of the component side. Now, since it's going through the distribution amplifier and then it's going through the LM1881 here, there's got to be like a little tiny bit of delay. But to the naked eye, I can't really tell, like, that there's any noticeable latency. And that's the only thing I was kind of curious about. I'm not really trying to like prove anything here. I'm just more curious, to see how much of a difference there actually is. And so I thought I'd, record it and, maybe like share it, but there isn't really like any particular direction I'm trying to take with this video or anything. It's just more of like an experiment than anything. All right, so I've got everything hooked up now. Let's bring the scope up here on the corner. And as you can see, it's just running kind of wild right now. So the top line, this yellow portion here, that's the composite video coming straight out of the PS2. This blue line, that's the Y signal coming out of and it just crept out. Why? Oh, I guess it's kind of not making very good contact here. Let me fix this a little bit. There we go. Okay, so this the blue one here, that's just the Y output coming out of the component output on the RGBS to YPbPr converter. So I'm going to stop it, and then we're going to zoom in and see if there's any noticeable delay between the two. I'm pretty sure there should be some, but let's see how drastic it is. So I'm going to do single here, and that's a little loud there. Let's turn that down. Okay, let's see. Let's try to zoom in, and let's move this over right there. And yeah, there we go. There's definitely a tiny little bit of delay, but it's so minuscule that it's like not even noticeable. Okay, so I decided to redo things a little bit here and actually capture 3 points. So the yellow is still the composite video coming straight out of the PS2. The blue is the component output on the Y of the little box. And then the purple up here, that's the composite video going into the box. So we'll be able to see how much delay there is between the output here through the distribution amplifier and through the converter. And we'll be able to see how much delay there is between the composite video input of the converter and the output of the on the component side. So I've already captured that, and I'm going to have to take a screenshot here because unfortunately the cursors do not show up on the little capture window here. So let me do that real quick. Okay, this ended up being a little bit more of a hassle than it should have been. But the first USB device that I tried to plug into my scope to capture one of the screenshots of the pulses, it like totally made the scope crash, and I couldn't recover it after that. So I had to turn it off and power it back on. So I tried a different USB stick, and that one, it just refused to recognize. It wouldn't even say that anything was inserted. So then I finally tried the third thing with a USB to SD adapter. And I saved it onto like a 1 gigabyte SD card, and I was finally able to get some images from that. So let's take a look at what we've got. And this is the first image. And because my screen capture here is smaller than the actual display, it gets cut off a little bit. But as you can see, we've got all the traces set to a 500 millivolt per division. And I rearranged the order of the colors here. So the yellow one is the composite video coming out of the PS2. The purple one is the video after the distribution amplifier, and then the blue one is still the signal coming out of the on the component outputs of the converter box. So this is the area that we're going to be looking at right there, just where this pulse goes low on all of these traces. So if we take a closer look at those, we can see this is what they look like, and this is like super stretched out there. So as we can see, between the output of the PS2 and the output of the distribution amplifier, there's about a 36 nanosecond delay. And I try to get these, as best as I could to where they were both about at the point of where the signal there's dropping. So it appears that it's about there. And for the distribution amplifier output, it's about there. So yeah, that's about 36 nanoseconds. And then the second one is from the, I think I've got this one a little bit shifted right there, but it's about 220 nanoseconds or so between the output of the PS2 and the output of the converter device. So you can definitely see that there's a bit of a propagation delay after it goes through all the devices. But if we were to remove the distribution amplifier from the equation here, we'd see that we'd have a pulse width of about, or a propagation delay of about 186 nanoseconds from the time that the signal goes into the box and the time that it comes out from the component outputs. But all this here being in the nanoseconds means that it's really not going to be perceptible at all to like the naked eye. Because if we're talking about like, 60 frames per second outputting on the component device, that's going to be about 16.6 or 7 microseconds per frame. And this is like super, like way down there. So it's not even a one like frame as a worth of like time. So it's really not going to be noticeable. And regarding the footage that I recorded, where I was recording both of the TVs to see if there was any perceptible difference between the small TV and the large TV, I honestly, I can't tell from just watching it. And when I import all the footage into like Resolve, I'll try to like slow it down and put them side by side so that we can get a better look at it. And maybe we'll be able to see, maybe a little tiny bit of difference there. And even then, I don't know that we're actually going to be able to tell, to be honest. So as far as this setup goes, yes, there is some propagation between the output of the device and the output to the TV. And I can already hear some people asking, well, why don't you just go straight from this to the TV using like a component cable or something? Well, that's because I'm not intending to use like a PS2 or any other device like that can output component video already and put it into that TV. I've got other purposes for it. And so I'm just using this as like a test setup to make sure that things are actually going to work the way I want them to. Oh, crap. I freaking spilled beer on my bench. These are what I actually want the RGB input for. And it kind of sucks that I can't natively do RGB input into that TV. And so that's why I'm going to have to use this adapter. Thankfully, as we saw, the quality on it is really not bad. And so I think it's going to work quite well. I just wish I didn't have to use something, you know what I mean? And I'm sure there's going to be some people out there that are going to recognize these right away and they know exactly what they are. Or maybe you want to take a guess as to what these are. Leave a comment down below. We'll see if you're right. And as I said, there wasn't really any particular direction that I wanted to take this video in. I mostly just wanted to play around with this thing and see what sort of like signal propagation delays they had going on. And, as we saw, it's really like so tiny that it to be like negligible, like all things considered. So that's pretty much going to do it for this one. So if you stuck around, thank you all for watching. I will see you guys around the bench.